So we said, no, we're just going to leave the gorse alone on this gorse-infested pasture. We don't want pasture, we want native forest to regenerate, and gorse is a wonderful nurse canopy for native forest regeneration.
What if the secret to restoring a devastated landscape was not removing invasive weeds, but leaving them alone? On New Zealand's Banks Peninsula, botanist Hugh Wilson faced fierce criticism for refusing to clear thorny gorse from 109 hectares of abandoned farmland. Instead of spraying or bulldozing it, he allowed nature to take control. Over time, the dense yellow gorse sheltered young native trees, which slowly rose above it and transformed the land into a thriving forest filled with wildlife and waterfalls. How did a hated weed become nature's unlikely restoration tool? It all began with one controversial decision: the battle with gorse. In 1987, 109 hectares of farmland on New Zealand's Banks Peninsula lay in a state of near ruin, overtaken by dense thickets of gorse, a thorny shrub despised by farmers and conservationists alike. Gorse had long been classified as a noxious weed, targeted relentlessly with sprays, bulldozers, fire, and hand-cutting for nearly 9 decades. Yet every attempt to control it backfired. The plant grew back thicker, faster, and more aggressively than before. By then, over half of the property was engulfed in this yellow, spiny fortress, choking out pasture and native vegetation alike. The previous farmer followed the government's standard advice faithfully, but was ultimately defeated by the invasive shrub. Pastures collapsed beneath the canopy of gorse, the soil eroded, and life on the land dwindled. The cycle of destruction and regrowth seemed endless, with no clear solution in sight. Far from being a minor nuisance, gorse had become a landscape-defining force, emblematic of human attempts to fight nature without understanding the deeper ecology involved. This land wasn't just overrun. It was sort of fighting itself, struggling to mend beneath all that human mismanagement and those invasive plants. And to make things honestly worse, the whole community seemed convinced that getting rid of gorse was the only way ahead, like a belief that came straight out of decades of policy and other failed interventions. Still, the gorse kept showing up, stubborn and plain, and that persistence suggested there was more going on, like something tucked under the thorny face, waiting to be figured out. At the center of the whole argument, there was this question that kept coming back. It haunted both the farmers and the conservationists. Could that relentless invader be truly controlled or somehow reshaped? Banks Peninsula, in its condition, felt like proof of the old approach going wrong, because forceful eradication only seemed to feed the very cycle it was trying to stop. Cutting it down, slaying it, again and again, just left the place more open, more empty, more exposed. So the scene was basically ready for an approach nobody expected, one that would mess with what everyone had accepted for years about land management. And it's here, in that mix of frustration and disappointment, that a different notion started to catch hold. Not a plan based on destruction, more like patience and looking closely. The new direction depended on seeing the gorse not only as a weed to remove, but as a possible helper in ecological recovery, a kind of reluctant ally. Of course, admitting that was seen as radical, and it came with pushback, real fear, real opposition, from neighbors and from the authorities too. Before anything could actually shift, someone had to buy into the idea that the answer wasn't only spray or flame, but maybe letting go, giving the land and this invader space to settle into their own balance. The moment that thought was put on the table, it got met with skepticism and open hostility, kind of a reminder of how far it was from the norm. And even then, it was still a bet that would take years to confirm, requiring a patience that, well, very few people felt like offering. This moment marked the beginning of one of New Zealand's most surprising and important ecological experiments. It was a turning point driven by a botanist's refusal to follow the usual script, a choice that would reveal the land's hidden potential and redefine ecological restoration. Hugh Wilson's radical choice. When Hugh Wilson acquired the overrun farmland in 1987, he made a decision that shocked everyone. He refused to slay the gorse. Wilson, a seasoned botanist who had spent years surveying the native flora of New Zealand, announced to his new neighbors that he would not spray, bulldoze, burn, or cut back the invasive shrub. Instead, he would let it grow in every thorny yellow acre. This was not just a management choice. It was a statement that challenged nearly a century of entrenched thinking. The response was swift and harsh. Local newspapers published letters calling him a fool and a dreamer, warning that he was destroying the land's future and threatening to bankrupt farms across the peninsula. Officials required him to clear a strip of gorse along property boundaries, but allowed the interior to thrive. Neighbors kept a watchful eye, convinced that Wilson's approach would result in ecological disaster. The skepticism reflected the deep fear that tolerating an invasive weed would mean surrendering to decline. Yet Wilson's knowledge of the land provided a different perspective. His surveys had shown that before European settlement, Banks Peninsula had been covered in native forest, now reduced to less than 1% of its former extent. More revealing was his discovery beneath the gorse, native seedlings quietly growing in the shade, invisible to farmers focused only on destruction. This was a hidden form of resilience, a secret regeneration happening under the very plant most people wanted gone. Wilson saw that the gorse had this unexpected role. It was basically nursing for the recovering forest. Its dense, thorny canopy built a kind of protective fortress, and it shielded new native plants from hungry grazers. It also improved the soil by fixing nitrogen. After that biological insight, the idea of gorse went from being just a straight-up villain to more like an essential pioneer in ecosystem repair. Still, getting others to believe it took time, careful scientific rigor, and real proof that nature could manage on its own schedule. For over 10 years, Wilson had to sit with criticism and isolation, while he kept doing studies that other people kept brushing aside, and at the same time, he ran the reserve. No car, and he lived plainly on the property too. His dedication was quiet, but it never wavered. Around him, though, the neighbors' doubts stayed hanging there, because the gorse looked the same. The yellow waves kept rolling across the hills. And yeah, the long wait for recovery was hard for a lot of people to swallow. The turning point came a while after, nearly a decade later, when the first patches of gorse began to sag and collapse under their own weight, like the place was quietly giving up. Native seedlings that had been growing out of sight started to overtop the dying gorse, and in doing so, they loosened the canopy. Then sunlight got a clear path, and it started feeding the forest floor. That slow, almost steady procession, once treated as a joke or a not possible thing, still showed how Wilson's belief in minimal interference was actually working. The skeptics, who had stared and doubted, kind of waited for it to fail. They could not really deny the early signs of change anymore. Wilson's bold choice, to do nothing else but protect the gorse while also removing threats like grazing animals, pushed against the usual restoration way of thinking. It felt like an experiment built on trusting ecological processes instead of forcing human control. His story would turn into a notable case study, not just in what happens, but in how patience and respect for nature's own rhythms can reach results that sheer force cannot. The hidden seedlings beneath. One of the most astonishing discoveries Wilson made was the presence of native seedlings growing silently beneath the gorse canopy. Species like Canuka, Maho, Fuchsia, Wineberry, Lemonwood, and Five-Finger were sprouting without planting or tending, shielded by the dense thorns. These seedlings were plants that could not survive in open pasture but found refuge under the gorse's shade, a secret forest in waiting beneath a sea of yellow. This hidden growth was overlooked by farmers focused on removing gorse purely as a weed. The discovery challenged long-held assumptions that gorse only hindered native vegetation. Instead, it revealed a natural succession underway, a process where gorse, though invasive, was creating soil conditions and shelter necessary for forest species to establish. It was an unintentional alliance between an introduced plant and native flora. The key to this process lies in gorse's biology. As a member of the legume family, gorse fixes nitrogen, enriching the soil in ways that degraded farmland desperately needed after a century of grazing and erosion. Its deep roots and thick canopy protected the young native plants from herbivores like sheep, deer, and goats that otherwise would have eaten the saplings before they could grow. This created a safe nursery space for the forest to regenerate naturally. Wilson captured this insight in a 1994 publication, explaining how gorse grows rapidly early on, then reaches a point where its own stems collapse, opening the canopy. At this stage, the gorse can no longer regenerate in shade, but native seedlings thrive in the filtered light. Over time, these native trees overtop the dying gorse, shading it out and causing it to die and compost back into the soil. This natural transition transforms gorse thickets into mature native forest. The presence of these seedlings beneath the gorse illustrated that restoration did not necessarily require planting or clearing, but patience and ecological understanding. It suggested that native forest could return on its own schedule if given the chance. This quietly growing forest was nature's proof against decades of aggressive gorse eradication policies. As neighbors watched the gorse grow unchecked, few realized this hidden succession was happening. The visible yellow might have seemed like a nightmare, but beneath it was a forest waiting for light and time. This underground story reframed the invasive weed from enemy to nurse, a vital stage in a far longer ecological journey. Recognizing these seedlings was essential to shifting attitudes about restoration, lighting the way toward minimal intervention. It was the key detail that would eventually convince even the most skeptical neighbors that nature could heal itself, and that letting go could sometimes be the most powerful act of stewardship. The seedling hidden beneath the gorse canopy planted the hope of renewal, setting the stage for a forest to reclaim the land in ways no one had imagined possible. Gorse's role as a nurse plant. To understand how gorse changed from a hated invasive weed into a powerful restoration tool, we need to look at how the plant works. Gorse belongs to the legume family, along with clover and beans. Through bacteria living around its roots, it can take nitrogen from the air and add valuable nutrients to poor soil. This became especially important on Banks Peninsula, where decades of grazing and erosion had left much of the land damaged and exposed. Gorse was one of the first plants capable of surviving those harsh conditions. As it spread, it slowly improved the soil, creating a foundation where native plants could eventually return. Its thick growth also provided physical protection. Mature gorse can reach about 3 meters tall and form dense walls of sharp thorns. Sheep, cattle, goats, and deer struggle to move through these barriers, meaning young native seedlings growing underneath were protected from grazing. The shade beneath the gorse was equally important. Many native forest plants could not survive in open pasture under direct sunlight. However, they could grow beneath the filtered shade of the thorny canopy. What appeared to be an impenetrable weed field was actually becoming a sheltered nursery for the next generation of native forest. Hugh Wilson kind of laid out this process in a 1994 paper. Gorse grows fast in those early years, making really tight little thickets. And then, after about 10 years or so, the thick stems start to collapse. That collapse creates small gaps where sunlight can finally reach the enriched soil underneath, more or less. Then native seeds, the ones carried by birds and wind, show up and sprout under that weakening gorse. A lot of these seedlings can handle shade way better than gorse does. So they just sit there, almost quietly, under the canopy before slowly getting taller than it. And this turns into a major shift. Gorse basically needs strong sun to keep going and reproduce. But as native trees rise and spread their branches, that sunlight gets blocked off. The gorse then weakens, dies, and decomposes, which feeds the soil even more. Over time, the thorny scrub ends up giving way to native woodland. The plant people, once blamed for stopping restoration, become the very mechanism that enables restoration. On Banks Peninsula, they talk about it as one of the quicker natural routes from degraded farmland back to native forest. Wilson's choice not to spray or bulldoze the gorse wasn't some easy, neglectful sort of thing. It was driven by his idea that ecological recovery can happen with patience and only light interference. By keeping grazing animals, pests, and fire away from the area, he let the relationship between gorse and native plants unfold on its own, more or less. So the outcome sort of pushes back against the notion that every invasive species has to be destroyed right away. In the right conditions, an introduced plant can temporarily act like a nurse, shielding seedlings, rebuilding soil, and setting up damaged land for native forest to come back. As this natural succession quietly progressed, it began to break down barriers of skepticism, setting the stage for a landscape that would soon astonish even the harshest critics. The slow return of native forest. By the late 1990s, the transformation at Hugh Wilson's reserve had become impossible to ignore. Gorse shrubs began collapsing under their own weight as native trees such as Kanuka and Maho rose above them. Sunlight reached the forest floor, triggering a wave of native seedlings and marking the return of a self-sustaining forest. Even skeptical neighbors changed their minds. Farmers who once feared gorse would permanently ruin the land watched native trees steadily replace the yellow thickets. Within a decade, areas once dominated by gorse had become increasingly green with young forest. Photographs taken from the same locations since 1988 captured the dramatic change. By 2016, hillsides once covered in bright yellow gorse had become dense native forest with towering Kanuka, tree ferns, and almost no visible gorse. The images confirmed Wilson's belief that gorse was only a temporary stage in forest recovery. What made the restoration remarkable was what did not happen. No trees were planted, no large-scale herbicide was sprayed, and no major earthworks were carried out. Wilson simply fenced out grazing animals, controlled a few destructive pests, and prevented fires, allowing natural succession to take over. This approach challenged conventional restoration methods, which often rely on expensive weed removal and planting programs. Instead, Hinawai Reserve proved that patience and minimal interference could produce outstanding results at a lower cost. As the forest expanded, native birds returned, waterfalls flowed year-round, and hundreds of native plant species flourished. What began as abandoned farmland covered in thorny weeds became a thriving ecosystem. Hinawai showed that nature often knows how to heal itself, reminding us that sometimes the most powerful form of restoration is giving the land the time and freedom to recover on its own. Sometimes, transformation begins not with intervention, but with the courage to let nature take its course, revealing a future brighter than anyone dared to imagine. A living model for restoration. Today, the 1,700-hectare Hinawai Reserve stands as proof of nature's remarkable ability to heal itself. Once covered in gorse, the land is now largely native forest, with about 4% classified as old growth, 6 times the average on Banks Peninsula. This recovery happened without planting a single tree. Instead, Hugh Wilson allowed natural succession to take its course. The reserve now supports around 350 native plant species and at least 35 native bird species, including tui, bellbird, kereroo, rifleman, and the New Zealand falcon. Their return reflects a healthy ecosystem where forests, wildlife, and natural food webs have recovered together. The landscape itself sort of changed dramatically. Now 47 waterfalls move year-round as restored forests stabilize the hillsides, ease erosion, and hold more water back. Land that used to dry out each summer now kind of carries thriving streams and all that abundant life. Wilson's strategy was, oddly enough, pretty straightforward. Keep grazing animals out, manage a few invasive pests like possums, goats, and deer, and stop fires from taking hold. There weren't any huge tree planting drives or that kind of broad herbicide use people expect. By letting nature lead the way, restoration stayed relatively low in cost while the forest regenerated by itself, slowly but steadily. The reserve also ended up financially self-supporting, bringing in about 1 million New Zealand dollars a year through carbon credits, donations, and visitors. Wilson's idea that native forest would reclaim nearly all the land has turned out to be close to the real thing. This has earned respect from scientists and even some earlier critics who were not convinced. Today, Hinawai Reserve is basically a living example that successful restoration does not always need more pushing and pulling. Sometimes the most effective fix is simply giving nature time and space to heal, showing that patience can do what human effort alone often cannot, no matter how determined people feel. Hugh Wilson's refusal to eradicate gorse transformed degraded farmland into thriving native forest without planting a single tree. This story shows that patience and respect for natural processes can achieve restoration far beyond conventional methods. If this changed how you see the power of nature left alone, like and subscribe for more stories that challenge what we think is possible. Thanks for watching, and continue the journey by clicking the next video appearing on your screen to discover another remarkable story of nature's ability to recover.